Hello everyone, my name is Hardeep Singh, and in this project I'll walk you through how I applied the machine learning modeling process to predict the early electrical energy output of a combined cycle power plant. I will cover how I identified this as a regression problem, explored and selected the right features, built and compared multiple models in Microsoft Excel, evaluated their performance using RMSE and R², and interpreted the results to select the most accurate and simplified model. Let's begin with an overview of the problem and the dataset. The goal of this project is to predict the net hourly electrical energy output of a combined cycle power plant. The dataset consists of nearly 9600 hourly readings with 4 environmental factors, including temperature, ambient pressure, relative humidity, and exhaust vacuum. The target variable is the energy output measured in megawatts. Since the target is continuous, I identified this as a regression task. My initial approach was to include all 4 features and evaluate different linear regression models to find the best predictor of energy output. I, I placed the entire data in an Excel sheet like this. Then in the step 2, I started with exploratory data analysis in Excel using summary statistics and visual charts. Scatter plots revealed strong negative correlation with temperature, as you can see here, moderate impact from exhaust vacuum, and very little contribution from humidity. For model building, I tested 2 regression models. One, a multiple linear regression including all the features, a simplified model excluding relative humidity. I used an 80-20 train set split and calculated validation RMSE to compare the models. With model without humidity produced a slightly lower RMSE, making it more accurate and simpler. You can see the data how I calculated the predicted model 1 and predicted model 2, and squared errors model 1, squared errors model 2, and then calculated the RMSE model 1 and 2. I used regression add-in in Microsoft Excel to calculate the coefficients and the entire statistics around regression modeling. Using the coefficients, I calculated the RMSE of model 1 and 2. Next step, final model and evaluation. The final selected model includes temperature, exhaust vacuum, and ambient pressure. The regression equation goes like this. Using the coefficient and the features, this model achieved an RMSE of 2.45 megawatt and an R² of 0.9, meaning it explains 90% of the variance in energy output. This confirms that the chosen model is both accurate and generalizes well. Now comes up the interpretation. This chart shows the predicted energy output versus the actual output for the test data. The predictions are closely aligned with the diagonal line, indicating strong accuracy. In terms of feature importance, temperature has the largest negative impact on energy output, followed by the exhaust vacuum. Ambient pressure has a small positive effect. Removing relative humidity had no negative impact on accuracy, confirming it's not a significant predictor. Finally, the key learnings. Through this project, I learned the end-to-end process of developing a machine learning model, identifying the task, exploring the data, building and comparing models, and evaluating them with clear metrics. As the next steps, I could experiment with polynomial features or interaction terms and explore advanced models like decision trees to capture non-linear effects. However, this exercise demonstrates that even a basic regression model in Microsoft Excel can predict plant energy output with a high accuracy. Thank you.